No one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or a few API calls. MongoDB Atlas automates deployment, automates updates, handles scaling, and more so that you can focus on your application instead of taking care of your database. You can get started free at mongodb.com/atlas. Now, if you're already managing a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime and then get back to what matters. Stop managing your database and start using MongoDB Atlas. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Meka Egwuekwe. He's the Executive Director of CodeCrew. How are you, sir?
Doing well. How are you today, Scott?
Living the dream, but I'm happy to be talking to you because you are creating new techies, new programmers. You are apparently an incredible ambassador for the technology scene in Memphis.
Well, you're very kind. I definitely am one who preaches the gospel of computer science education to kids and adults here in Memphis. So with CodeCrew, and I know we're going to talk a lot about it, but it is my life's passion is what my calling is.
Mm-hmm. And how did this get started?
We started, myself, Petya Grady, and Audrey Willis, the three of us come from tech backgrounds. We came together in May of 2015 to launch CodeCrew after having worked together through another tech education program called Black Girls Code, which I'd love to shout out Kimberly Bryant and her excellent program where we all started. I was really just trying to sign my two daughters up for that, but before I knew it, I was leading the chapter in Memphis. And then the three of us, having come together through that experience, decided to launch this separate nonprofit with some support from the Memphis Grizzlies NBA team to actually bring a tech mentoring program to a community center where they've been active.
Nice. We had Kimberly on the podcast in 2012. She's show 303. We had her on before she had started her nonprofit. She had the domain and was waiting for her nonprofit status.
Wow. Okay. Well, that's great then. Well, she's amazing. She may have shared that she herself is from Memphis, but now lives in San Francisco in the Bay Area. But she gave me the honor of launching her hometown's first chapter, Black Girls Code, and that we made into an active success while we were there, and it still continues today. Three of us decided to go in another direction and launch CodeCrew. Mm-hmm. And that has grown now from what was a single summer camp to now multiple in-school electives classes, after-school programs, teacher trainings. We've gotten legislation passed at the state level for computer science education. And we've got this adult coding boot camp that we launched a couple of years ago, too. So lots of layers now to the CodeCrew experience.
Excellent. Let me ask this and just start with this. Why are programs like this needed? Why can't someone just, quote unquote, just go to community college or go to a four-year school to learn their tech?
You can, certainly. And there are numerous success stories of people following those more traditional paths. However, those paths have not worked for everyone. And so, in fact, a good number in our adult program, a good number of our students, in fact, most of our students have tried college before and it hasn't worked out, right? And for one reason or another, life interferes, whatever happens to in their lives. And then they deserve an alternative pathway into careers like these in tech and especially in computer science and software. They deserve to have alternative pathways to get to these careers without having to be limited to the traditional approach. Especially if they already have the aptitude, they just really need access to an opportunity. And so we also look at the reality that our colleges and universities, including community colleges, are not meeting the demand for talent. Right. So, they're not. In fact. And I should have brought some numbers to quote here, but I'm pretty sure they're not even meeting half the numbers in terms of open computing positions. That, and then when you look at colleges and universities, and don't get me wrong, I love college and university. I went to college, Morehouse College, and then went on to get a master's in computer science from Duke. So I believe in education. But when you look at what is taught, you're not necessarily trained to be a software engineer. You're trained around computer science in general, which is all helpful, right? And all good things to know. But coding boot camps are much more narrowly focused on producing those ready to work software engineers. And so I think any healthy tech education ecosystem involves multiple ways, from community college to four-year college to graduate school to coding boot camps, as pathways to produce the tech talent that we need.
Yeah, I feel like my own background was non-traditional in that I went and visited a four-year college, knew that I was not going to cut it, got really down, moved into my parents' garage, and then went to Portland Community College for 2 years and got a job without a degree. Spent 11 or 12 years in tech until I finally finished my bachelor's from Oregon Institute of Technology, which is a state school here in Oregon, in 2003. But I think that the privilege that I was afforded was that once I had been in tech 5 or 6 years, everyone stopped asking about whether I had a degree. So it was quite awkward in the early time there. Like, do you have a degree? Do you have a degree? Everyone wanted to know about your degree. But if you can get in and stay in, then that degree stops becoming a piece of gatekeeping that people will use to keep you out. Do you find that to be the case?
Well, I do and I don't. I certainly have seen multiple stories like your own, where that don't have a degree and have had successful careers in tech. I have found that for some, especially if you are female or African American, it's less easy to do that, and especially reaching a point where you have a ceiling, if you will, in terms of how far you can climb without a college degree. And so I still.
Indeed.
Big advocate for people getting a college degree. In fact, even our coding boot camp at CodeCrew, our adult program, is actually housed at the local community college, Southwest Tennessee Community College. And so those who do our coding boot camp can earn up to 18 hours of credit towards an AA degree from Tennessee Community College. And so, and I definitely encourage them to take advantage of that, earn that degree, just so you don't run into that ceiling, because most of our students are from an underrepresented group, either they're African American, Latinx, or female. 90% of them are, and so that is so that's the reality. I tell people not all the time, but I've said from time to time that the stories like yours I've like I said, I spent 19 years as a software developer, so I've seen lots of stories. Stories like yours, I've seen quite a few white guys do that. My list of African Americans I've seen do that was a short one until we launched our coding boot camp.
Indeed.
We've been able to that narrative, but there's still a lot of work to do.
Yeah, I found that once I had moved out of the neighborhood and put a suit on, where I came from mattered less, and that was my privilege. And that's what enabled me to basically avoid those questions, while my Black friends would even go back and get a master's degree to get that respect that they deserve.
Sure. And it was I'll be honest, it was a big motivation for me to earn a master's degree. It's a mistake that I have a master's degree in computer science. It recognizing that reality. But of course, I did that back in 1996. It's a different time than now to some degree, but then again, not all that different.
Right. So we definitely want to make tech a place that is not going to require people to go over those hurdles unless they want to. And I really love that you're combining the best aspects of a boot camp, of a coding camp, but the idea that you're also getting credit to potentially go back and do an AA is really genius. It's a very smooth on-ramp. It feels like a welcoming on-ramp into technology.
Yeah, thank you. I mean, we again, it reflects our values. We still value a college education, but at the same time, you technically don't have to have a college education to begin a career in this space. And
Indeed.
So we encourage that, but ultimately, we want people to have careers and in this space, or pursue entrepreneurship in this space. And if you're going to follow the career path, then ultimately, it'll still benefit you to have a college degree.
Why do you think that given that we need more coders, that we need more architects, that we need more software engineers, why do you think that the way that computer science is taught traditionally, whether it be in a big name 4-year school or a smaller trade school or community college, fails so many people? What 101 level classes are we teaching that people are just giving up on that keeps them from getting a long career in technology?
Well, I mean, I don't know if it's failing so many people. I mean, it is failing some. Like I said, I don't think that is unique to computer science or software development. I think there are challenges with college for people across the board. That being said, when I look at computer science, you take a lot of math in a 4-year college, for example, a 4-year degree, and in practice, using that math, and as a software developer, 99% of the math I did was algebra. And so for some people who may be great at software and getting machines to do things in efficient ways and in very expressive and creative, they might run into a calculus roadblock. And so should that stop them from becoming a software engineer because they didn't do well in calculus? I don't think so. I think that we have room for diversity of experiences as in software development that, you don't necessarily have to have calculus to do this. I'm a huge fan of calculus, and my kids laugh at me because I actually enjoyed calculus. And so those kinds of, there's some additional requirements for 4-year degrees that I think are, any additional knowledge is helpful, but is that always necessary for some of the roles that we need filled in tech? That's a worthy question.
It is a challenging question as well, because I am, ashamed, but also not ashamed to say that I had to take 2 solid runs at calculus and it almost broke me. And I can also say declaratively that I am a good programmer and I've enjoyed a long career and I have been, better than mediocre in my programming, but calculus didn't snap for me and it almost broke me. And when I finally got out with a C+ in calculus, I was like, man, I hope I don't have to do this every day. Now, if I was making video games and doing, matrix transforms, I'd be doing some different upper level algebra. But in 30 years of programming, I haven't really bumped into calculus on the regular. But it was absolutely required, and it wasn't just one class; it was a full year of math that almost prevented me from getting my degree. But I don't want to say that calculus has no value and that we shouldn't try at least,
Right, exactly. But you're an excellent example of what I'm speaking of, right? That calculus wasn't your friend necessarily.
Fair.
But you still were able to have a successful career in the space. And so I think those kinds of barriers we ought to re-examine in how we're producing the talent that we need. And that's why, again, I think we ought to have an approach that there's a comprehensive set of alternative methods or comprehensive set of methods for achieving careers in the space that are not limited to just the traditional path, even though that's the path I followed.
You called out something a few moments ago about the difference between computer science and software engineering that I feel is worth digging into a little bit, because that's been a little bit of a kind of a low key feud amongst the academics that feel that computer science, certainly it has value, but it's the abstract understanding of the machine, and it involves a lot of history and building your own operating system and things like that. But it doesn't teach you test-driven development and modern programming practices, which is what software engineering usually does. One seems to be doing it, and the other one's more kind of the history of doing it.
Well, I mean that's one way to look at it. I sort of just simply see software engineering as a sector of computer science, right? That it is the sector. Software engineering is that sector that is about building software systems to solve problems, right? And in all those cases, in all the sectors of computer science, you're building software, obviously, but software engineering is that discipline of, practical applications of computer science to solve problems, usually in like a business context, right? Whereas there are other elements of computer science, right, that obviously involve software, right, but aren't about software engineering necessarily, right? So for example, there's research in computer science, right? And some of the things we take advantage of today, like were things like cloud computing, for example, were things that we were talking about when I was in grad school in the mid-90s, right? And that was a branch of computer science that was worth studying that wasn't necessarily tied to software engineering. But then that body of the research eventually developed and matured to a point where you can build businesses around it and therefore employ some software engineers, right? And so there's artificial intelligence, the same story, right? In fact, when I was in grad school, we used to kind of laugh about AI because it had been stuck in the same place for like 40 years, right? But now, it's actually come to fruition where it's, who doesn't have Alexa or Siri or Google Assistant, right, as part of their lives today. So there are multiple branches of computer science, of which software engineering is one of the disciplines there, but it's not the only one. And I think so that's why I do see the value in a computer science degree, because you still get that breadth of the field, even though you're going to select one aspect that you're going to probably spend most of your life doing. So
Indeed.
That's kind of how I see it.
When I think about gatekeeping, sometimes I think to myself, well, I'm glad that gate was there and I clambered over it, or I picked the lock, or whatever I did. When I wanted to drive in the late 80s, and I learned to drive mid 80s, my dad said, you can't drive unless you learn how to drive a stick shift. You have to use a manual shift car, and you can't drive until you change your oil, and you can't drive until you can change a tire.
Right.
But in 2020, I've got my son is going to be in 2 weeks old enough to drive. He might just say, I want to take an Uber. Am I gatekeeping if I decide to tell him he has to change a tire and fix the oil too when he's going to be in an Uber? Do you see the analogy for someone who's joining in tech? Should I insist that you can't do HTML until you can write a compiler with Lex and Yak?
Right. I see that. And that's a great analogy. Yeah. I mean, here's the thing. I mean, there's so many opportunities, and the space is so broad, and the talent that we need is still not sufficient in number, right? People that can do these skills, that we ought to, again, have conversations and evolution, if you will, of how we're developing the talent that we need, in practice as a reality, and all of it's skilled talent, right? It's not unskilled, right? And so, it is worth revisiting. What should the 101 courses be? What should the gates be in terms of what's required, right? And that's always been an evolution of this industry, right? When I came into college, the class before me was required to take a database class. The class when I came in, we were no longer required to do databases, even though ultimately, in practice, you still need to know databases, right? But we had an additional algorithms course that was required, right? And so there's always been this evolution, but I think that it's almost more intense now, given how pervasive software is in all of our lives. I tell kids all the time in our program that I drive a Toyota Prius, and it's got like 30 plus computers in it or something, right? And so that's the software is just. There's not a day that goes by that, for the most part, an American doesn't engage with software, and probably increasingly so. There's not a day that goes by that a human doesn't engage with software. My father's from Nigeria, and I promise you, software is everywhere, just like it is here.
Hey, friends! I want to tell you about one of our sponsors, Text Control. They're not only the creator of the fully featured document editor library for .NET and Angular apps, but their libraries also have powerful PDF functionality. So you don't have to program PDF documents. You can make MS Word templates and then merge them with data, and that'll let you create pixel-perfect PDF and PDF/A documents. The best part is fillable form elements like text boxes and checkbox fields and drop-down elements, and you can add those easily to your PDFs and make filling out forms really simple for your users. And don't forget, TX Text Control gives developers a complete solution to handle PDF documents in any business process. So check it out. You can try it free. See the live demos at textcontrol.com/demos. Just that easy. textcontrol.com/demos. It's interesting that you bring up the car example, and I assume that kind of philosophy is expressed to the kids and the adults that go through the programs that you have at CodeCrew, because it sounds like what you're describing is systems thinking. You know, you can get into the car and start driving around, but if you really think about the systems involved, from the traffic robots that you're going to be passing and the computers behind that, there's a lot going on that we can either take for granted or we can peel back a layer, and then there's computers and algorithms and data structures underneath our everyday lives.
Well, there is, and those things are not decreasing in our lives; they're increasing, and I think that's all the more reason why computational thinking needs to be further integrated into our educational system from much younger ages than college. We are active members in the CS for All movement. That's a great organization based out of New York. They have annual summits. We convinced them to have their next summit in Memphis next year, right? But we all believe, whether CS for All, CodeCrew, Code.org, that computer science is foundational, that computational thinking is foundational, and for the reasons that we're stating, that these things are increasingly pervasive in our lives. We need to understand these things in terms of how they work, as well as, for those who choose this as a career or choose it to be an entrepreneur, they can pursue that. And for those who don't, they still need to understand it. Plus, when you look at the pillars of computational thinking, like pattern recognition, algorithms, decomposition of large problems into smaller ones, or abstraction and those kinds of concepts, those things actually benefit. They're not limited to computer science. They benefit across multiple subjects. And so the world that we're in just increasingly demands it. I cite the example of like photosynthesis or electricity. We teach those things in school, right? All of us learn those things in school.
Mm-hmm.
And that's because they're relevant to our lives, right? Now, I am not a biologist. I'm not a doctor, right? But I still understand photosynthesis, right? I'm not an electrician. I am a software developer, right? But my oldest daughter's in college right now studying. She's pre-med. She's not going to be an electrician or an electrical engineer, yet she understands electricity. And so we've reached now a point where computational thinking, understanding that approach to solving problems is just absolutely necessary and foundational.
Where should that be taught? I mean, your daughter's going into pre-med, but she sounds like she is a computational thinker. She is a systems thinker. I did some volunteer work at Black Girls Code, and I gave the example of I had this room full of young people. I think they were all in high school, and I said, "Let's all become a programmer." And they're all excited. Let's be a programmer. And I said, "My toaster is broken." And I just paused and I just let it hang there. It was very awkward, like 20 seconds. And one of them yelled out, "Is there any power to the toaster?" And I was like, "Here we go. And there's a programmer right there." And then we spent about 20 minutes decomposing the problem, doing a binary search back and forth until the kids in the room discovered that the power was out to the entire neighborhood. And that's why I couldn't make toast.
Okay. Well, that's great. That's great. We've had these kinds of questions. I've never used a toaster one. I'll have to steal that one from you. But we'll do challenges with kids using concepts they understand, like, a peanut butter and jelly sandwich, and have them, if they're old enough to read and write, then have them write down the instructions for building a peanut butter and jelly sandwich, and then pass instructions to a human computer, and then we'll give that human computer real jelly and real peanut butter and see what comes out of that. Is it really a peanut butter and jelly sandwich, and or something else like a paper airplane
or peanut butter soup?
Yeah. So really, just taking concepts they're familiar with, and because your question was, when should that be taught? We believe at CodeCrew it should be taught K through 12. And beyond, really, but certainly that there's room for computational thinking as early as kindergarten, even earlier, really, but certainly as early as kindergarten. And we're inspired by what they're doing in the UK, because the UK was like the first G7 country to actually require computer science education at all grade levels. Right? And so we hold ourselves to that international standard at CodeCrew. And so we work with kids as young as kindergarten, and we do work with concepts that they're familiar with, from peanut butter jelly sandwiches to airplanes and paper airplanes and so forth. But eventually step them to where they're doing pattern recognition. They're doing decomposition of large problems into smaller ones. They're doing algorithms. They're doing abstraction and learning about these things in an age-appropriate way. And so we believe it should be taught as early as kindergarten.
That's really significant. I noticed that immediately when you started describing that, because you said, as an aside, you said, well, assuming that they can read. And that was like, oh, wow. Yeah, there's no reason you can't teach this kind of thinking K or pre-K. It's about a way to see the world, regardless of whether or not you're reading or doing advanced math.
That's right. That's right. And at kindergarten, some kindergartens can read, but many can't. And, we as human beings start to see the world differently once we learn to read anyway, right? For good and for bad, right? And so they being exposed to computational thinking while they still are at an age where they've not been, exposed to too much of the bad that comes with knowing how to read. It's not like this bad coming. I shouldn't describe it that way, but there's a great example on a television show called Brain Games that they take a kindergarten child and they give them this challenge that the kindergartner can solve it in 20 seconds. With the adult, it takes so much longer to do, right? And it is presenting words on the screen that are words that are names for colors. The word green, the word red, the word black, and so forth. But you present those words in a different color, and your challenge is you're supposed to actually say the color that the word is, that the text is actually in, not what the text actually says, right? And kindergartners can do that much quicker because they don't know how to read green and black and red, right? And so there's a different way that they see the world and think, and exposing them to computational thinking at that age just further widens their possibilities in terms of how they approach problems.
That is a really interesting example. Wow, yeah, because they're seeing the color of the word and not the glyph. As we get better and better at becoming readers, we see the entire word rather than seeing each letter. So we have to register the glyph versus register the color of it. I've done those tests, and they're very challenging.
That's right. And the older at least adults,
yeah, they're very challenging to me.
Adults are challenged at that, but kindergarten kids get that. They just see it differently. I mean, another example is, showing a school bus, showing the driver's side of a school bus, but drawing it. It's a drawing, and you show them the front and the back. They're identical, and you ask an adult what end is the front of the school bus, and adults are hit or miss in terms of getting it right, but a kindergartner would get it right every time because they recognize that the door is on the other side of the school bus, right? And so well, we adults we sometimes can be limited from our experience. So again, exposing kids to different ways of thinking while they still have not committed themselves to ways of thinking, right? Just further opens the doors in terms of possibilities for them. And we believe that. So I can go on and on with examples, though.
No, of course. Well, the Code Crew is not just helping, students, training teachers in grades K through 12, but also adults. How do you get adults that are maybe older or have had a career and are now shifting careers and maybe lack that neuroplasticity that the young people do? How do we get them to become computational systems thinkers as well and enter their career?
Sure. And it is challenging. And from our practice, the older the adult, the more challenging it's been, we've seen in practice too. But for 20 somethings, 30 somethings, 40 somethings, we've seen, better results. But, it is a challenge. It is, getting people to understand that they're in charge of the machine and they're making the machine do things and they're not breaking things. For example, really nothing that can't be undone, right? But we do have certain requirements though to enter our adult program. So we can't start with completely from scratch, but we do have a requirement that you at least have a high school diploma and have done high school level algebra, for example, as a point for our coding bootcamp. And we do have some aptitude questions that we ask about before you're admitted into the program. So, but for those who have this demonstrated aptitude, they just need to be exposed then to these these tools and mechanisms and approaches and methodologies for software development. And so even then, still about half, maybe just under half of those who start our adult program actually finish it. So even then, it's still an imperfect science in terms of getting everyone across the finish line. So it's not easy, and I wish I had an easy answer for you. But it's a challenge. But nonetheless, we're happy to say we've got successes of adults that we've moved from an average of just under $12,000 a year in income before they started our coding bootcamp to just under $50,000 a year in income after they graduate and are placed.
I think that's really great. The thing that strikes me about tech and about when someone enters tech is not only does it give them a sense of power, of creation, of stepping into their own power as someone that can, make something, but it also is the beginnings of generational wealth, isn't it?
It is, yeah, absolutely. And so you're bringing two things up there, right? Not only generational wealth, but creativity. And many people think of tech people as not being creative. And I think nothing's further from the truth, right? That you can be as creative and expressive and as a software developer or as a tech producer as you are in any other discipline. And in fact, some companies like Apple and others have been very astute at creativity and expressiveness through technology. And then I remember, like an old man, the other point that you made about what was the other term?
Generational wealth.
Generational wealth. Thank you. And that is. The tech sector has grown to become the largest sector of our economy now, right? And when you look at 5 of the top 6 largest companies by market cap in the world today, 5 of them are tech companies, right? And so only Saudi Aramco beats them out, right? And so it is definitely an equalizer with respect to getting access to generational wealth because of the entrepreneurship opportunities. The barrier to entry is lower. All you need is a connected computer, and you can produce the next whatever. Right? I wish I knew the answer as to what the next whatever is, because I'd be able to, but yeah. And so. And obviously, you need more than that. You need to connect with capital. You need to connect with a network that can help you. But the barrier to entry in tech is lower than, in terms of software development, it's lower than, say, if I wanted to start an airline, right, or something like that. And so yeah. So the opportunities for generational wealth are tremendous there, especially if you follow the entrepreneurship path. And so, it's something we preach about. Also, we actually have projects at the high school level. In fact, something that's funded by the state of Tennessee, where we work with kids at Memphis Academy of Science and Engineering, or MACE as we call it, specifically on them applying computational thinking to promoting generational wealth. In this case, they're actually building and working with financial tools to solve financial issues in their home. But we're getting them thinking about generational wealth in ways that they probably weren't thinking of prior to us engaging them.
Well, hopefully someone who will come out of CodeCrew will make the next wonderful something that we haven't been able to think about because we're later in our careers, you and I.
Well, absolutely. And I jokingly say that I want them to become so wildly successful that they would hire me one day.
There you go.
So, but certainly even if they don't hire me, please remember your roots and make a donation to Lift As You Climb so that other young people can have access to careers and be just like you as a CodeCrew graduate. So I preach that gospel all the time too.
Fantastic. Lift As You Climb. You can check out CodeCrew at code-crew.org. Thank you so much, Meka Egwuekwe, Executive Director of CodeCrew, for chatting with me today.
Thank you so much as well, Scott. I'm honored to be here. Thank you for the invitation, and it was a lot of fun.
This has been another episode of Hansel Minutes, and we'll see you again next week.